All right, today we're tackling something really cool. It's a super powerful statistical method that lets researchers take their biggest, most complex ideas and actually test them with real-world data. It's called structural equation modeling, or SEM for short.
So let's just jump right in with the big question, right? How do you take a really complex idea, something about human behavior or why people feel a certain way, and actually prove it with data? How can you show that one thing really influences another? Well, that's exactly the puzzle that SEM is built to solve.
Probably the best way to get our heads around this is to actually walk through a researcher's journey. We're going to follow along from the very beginning, just a simple idea, all the way to a full-blown statistically tested model.
Okay, so let's use a really practical example from our source material. Think about cardless cash, when you can just use your phone to get cash from an ATM, no card needed. A researcher might have a theory. They might think, okay, things like how secure people feel using it, how much they trust the bank, and just how easy it is to use. All of that probably plays into how useful they think the whole thing is.
And here's the key thing, right? These ideas, security, trust, usefulness, they're not simple numbers you can just jot down. You can't look at someone and see their exact level of trust. They're abstract. In the world of SEM, these big, fuzzy ideas are called constructs, and the entire point of this method is to find a way to measure them and then see how they connect to each other.
But hang on, before you can even dream of testing how, say, security affects usefulness, you have to stop and ask a much more basic question. Are you even measuring security correctly to begin with? It sounds obvious, but this is an absolutely critical first step.
And that brings us to what's known as the classic two-step process in SEM. Think of it like this. Step 1 is building the measurement model. This is all about proving that your tools, like your survey questions, are actually measuring what you think they're measuring. You got to make sure your ruler is accurate before you measure anything. And only when you've nailed that down, you move on to step 2, the structural model. That's the fun part, where you actually test your big theory about how all these ideas are connected.
To get that first step started, researchers often begin with something called exploratory factor analysis, or EFA. You could just think of it as a quick preliminary checkup on your data. And I love this analogy from our source material. It says that EFA is kind of like washing utensils that are already clean. You're pretty sure they're fine, right? You're not expecting to find a huge mess. But it's just a smart little cross-check you do before you start the main event, just to be sure everything is grouping together the way you think it should be.
This really gets at a crucial difference. You've got exploratory factor analysis, or EFA, which is all about discovery. It's like you're going to your data and saying, hey, just show me what you've got. How do you all naturally group together? But then you have confirmatory factor analysis, or CFA, and that's totally different. That's you going to the data with a very specific theory and saying, okay, I believe you're structured exactly like this. Now prove me right.
And that leads us right into the main event of this first big step, confirmatory factor analysis. This is the real test. This is where our researchers' carefully crafted theory has to face the cold, hard facts of the data.
Now, when you're doing CFA, it's not just one simple test. You're actually looking for 3 different kinds of proof to show your model is solid. You've got goodness of fit, convergent validity, and discriminant validity. So let's quickly break down what each of those means.
First up, you have goodness of fit. This is the high-level, big-picture check. It basically asks, does the theoretical map I drew actually match the territory of the real data I collected? You're checking to see if your model is even in the right ballpark. Okay, next up is convergent validity. This one zooms in on each of your concepts one by one. It's asking, do all the questions I designed to measure security actually stick together like they're supposed to? You want them all to point to or converge on that one central idea, almost like they're drawn to the same magnet.
And finally, we have the third check, discriminant validity. This is all about making sure your different concepts are, well, different. It's checking that your questions about security are only measuring security, and not accidentally bleeding over and measuring something similar, like trust. You have to prove that each concept is unique and stays in its own lane. Okay, so if you're thinking, wow, this sounds incredibly complicated, you're not wrong. For a long time, this kind of analysis was pretty much just for expert statisticians. But the really cool thing is that today, a whole new generation of software has made this super powerful technique way more accessible to, well, pretty much everyone.
And our source material points to 2 really amazing open source tools. First, there's JASP. Think of it as a really user-friendly point-and-click program.
It's awesome for just playing around with your data and getting instant what-if results. Then, on the other side, you've got RStudio. Now that's a serious powerhouse. It's all code-based, which means you can customize everything and even automate your analysis and the writing of your report.
And you know, the creator of a special package for RStudio talked about his motivation for building it. He was basically saying, I'm so tired of doing all this analysis and then having to manually copy and paste every single number into my research paper. Why can't these two things talk to each other? So he literally built a tool to automate that whole reporting headache, connecting the analysis directly to the writing.
All right, so we've gone on this whole journey, right? From a simple idea through all these complex statistical checks. So let's take a step back and ask the big question. So what? Why does any of this actually matter?
Well, the payoff is huge. At the end of the day, structural equation modeling gives us a solid, scientific way to take our big theories about how people think and behave and actually test them. It lets us move our ideas out of the world of "I think this is true" and into the world of "the data provides evidence that this is true." And maybe the most exciting part of all this is that this super advanced method isn't some secret locked away in an ivory tower anymore. Because of incredible and free tools like the two we just talked about, JASP and RStudio, the power to test big ideas is now in the hands of way more people. And that's a really big deal.
So that just leaves us with one last question for you. Now that you know there's a real scientific framework for testing these big, complex ideas about how the world works, what's that one theory you've always had, that one big idea you'd love to finally put to the test?